Hello and welcome back to Checkpoint Jumpstart Maestro training. This is part 2. I would like to remind you that there's an accreditation exam that you can take. It's at home.pearsonview.com/checkpoint. The exam number is 156-412. There is a $49 exam fee, but the exam is not proctored. You can take it anywhere at any time. You just need a web browser. Now, on to the training. Hello and welcome back to Checkpoint Jumpstart Maestro training. I'd like to go over some more useful command line utilities and config files. First, there are 6 security gateway modules attached to this orchestrator, and for the unattached or unassigned gateways, you can see the serial numbers of those gateways. For those that are already in a security group, you just have to mouse over and see them. But you really can't copy these serial numbers. It's just not very convenient. So if you log into the orchestrator, call that there's a command that uses the link layer discovery protocol, LLDP CTL, and it spits out a bunch of output. You can rep out, pull out just a specific string, and I should probably put the command there. And that will display the list of known security gateway modules that this orchestrator has received link layer discovery protocol frames. So this is handy because you can copy and paste from this as you need to. So the 2 unassigned security gateway modules end in 553 and 551. You can see them here. They're the first 2 listed. So I want to demonstrate some CLI shell commands. First, I need to get the lock. So you can manage security groups through the web user interface, but sometimes it's just easier to do some operations via the command line and scripting, for instance. Invoking CLI shell in a script can speed up repetitive tasks. That's just one way to handle repetitive tasks. So from CLI shell, you want to create a new security group. Type the command in correctly. And I happen to know that, I could show the security groups that exist and see which IDs are currently in use as a security group. And the IDs correspond here, security group 1, security group 2, those numbers correspond to the ID. So I'll just pick 3. And I can add a appliance to the security group. Add Maestro security group command. And since this is actually this demo environment is actually a dual site setup, I have to provide the site ID parameter. copied the appliance serial number above, paste it here. So that's very handy to be able to get the appliance serial numbers via the LLDP CTL command. I can add interfaces. So by the way, I should show this. If I want to delete an appliance from a security group, I can either specify the appliance by its member number in the security group or by the appliance serial number. And next I will type the command in correctly. And I will type the command in correctly. I assigned it to security group 3. But I'm fickle. I actually want it in that security group. So it's back. I have created a new security group, ID3. I added an appliance to that security group, and now I want to add some interfaces to the security group. A couple of more. So I've created the security group. I've added an appliance. I've added interfaces to the security group. Next, I might want to run or configure the first time wizard. By the way, to delete the interface, the command is delete. So delete Maestro security group ID, number of the security group, interface, and name of interface. And very helpfully, CLI shell tab completes possible interfaces for you. Earlier I showed you that you can get the appliance serial numbers from the LLDP CTL command. And I did that because I wanted to show you that command and how to pull the appliance serial numbers out of it. But if I want to add another appliance to the security group, there's actually an easier way. It'll tab complete the serial, and note the serial here is more than what I copied. Doesn't matter. So I've added that appliance to the security group without having to go into expert mode and run the LLDP CTL command pipe it through grep. So I want to configure the information for the first time wizard. And now you know the super secret password. And this can be either no or yes, and we'll say no. So now I'm going to actually create the security group. And there is an option that I could specify telling it don't confirm. So like in the web user interface, it takes a bit to verify the security group configuration, push it out to the security gateway modules, and now the security gateway modules will be restarting. And in the web user interface, I refresh, security group 3 is now displayed. If I decide that I don't want to create the security group, I can throw away the configuration that I have been working on, uh, and off it goes. There wasn't any unapplied configuration, so nothing actually got thrown away there. You can also see the details of the security group in CLI shell. In expert mode, this data is in a config file, which we'll look at in CLI shell, shell Maestro security group ID, and then number of the security group. Dump the information about the security group. So the Orchestrator has several ports depending on the model of Orchestrator. It may have different types of ports. You can see information about the ports on the Orchestrator. I want to see what type of port it is. So this port is currently defined as a management port. And we'll pick a different port. This port should be an uplink port. Yes, unless it has been changed. And then something near the right side, 170, should be a downlink port. Now you can change the type of port And so I could make it a management port or a sync port or an uplink port. I'm not going to make a change. That command is available. You can also set the port administratively down. You can configure the maximum transmission unit, MTU, of that port. You can configure the speed. And there's also a no confirmation option at the end, and that you can use to not have to go through the confirmation dialog. Next, I'm going to switch. Actually, I'm not going to switch yet. I had one more thing I wanted to show you in expert mode. There are two config files here of interest. This config file describes the orchestrator, so like backplane service networks that are used for the various communications, VLANs that have been defined, and so on. So like the chassis internal network here defines the IP address ranges for that. The sync network and so on, of varying degrees of interesting. The other command, or the other config file, shows the configuration of security groups, and on the orchestrator it lists all of the security groups that this orchestrator knows about. You can also find this file in the single management object, and there it has the security group information for that single management object. This shows the name of the security group, the VSX state, what uplinks are assigned to it, security group 2, security group 3. There's not a whole lot that's interesting in CLI shell on a single management object, except the fact that it's actually by default global CLI shell. And so setting changes that you make here in the global CLI shell will be synchronized out to the other security group members. And so if you have 20 security gateway modules that you need to make a change on, connect to one of them, usually the single management object, which is the first security gateway module in the list, and then using the global CLI shell, you make your change, and you don't have to do it 20 times, and that's a big convenience. In expert mode, I want to show just a few commands. So ASG policy. This is useful, for instance, to do the scalable platform equivalent of FW unload local. FW unload local, of course, unloads the firewall policy and essentially turns the firewall host into a router that is unplugged. Packets do not pass. So here, the equivalent is ASG policy unload. And there's an option in a non-scalable platform, Gaia, in expert mode. You can write a value of 1 to a magic device file /proc, PROC /sys/net/IP forward, and do that and FW unload local, so your firewall policy will be removed, but then the Linux routing will be enabled. So that essentially turns your security gateway host into a router that is plugged in. The equivalent in the scalable platform is, to add the -IP_forward option, except with two minuses. So pretty dire warning, and I'm not going to have it actually do that. Now, when you install policy, the management server connects to the single management object and installs policy to the single management object. The single management object then copies the new policy files involved in the new policy to the other security gateway modules in the group, and then they independently install the new policy essentially at their convenience. When they do it quickly, but it won't be instantaneous. And that holds true for access control policy and threat prevention policy. Threat prevention policy, at least starting with R80.10, with threat prevention policy in R80 versions of the firewall product, the threat prevention policy is also pushed out as part of a policy install. It'll be copied from the single management object to the other security gateway modules in the security group, and they will install the threat prevention policy essentially at their convenience. You can see the latest access control. Access control file or policy that was installed. It is at $FWDIR, which is an environment variable that expands. Into /opt/cp suite -r80.20/fw1. This is Linux. Linux is case sensitive, so you have to type the capital C, the capital P, the capital R, and everything else lowercase. To see the contents of this gzipped tar file, use the magic incantation tar space minus TVZF, TZVF, it doesn't matter. The -T option lists the files in this gzip tar file. The -V option does it verbosely. The -Z option says you're looking at a gzipped tar file instead of a non-gzip tar file. And then the -F option indicates what file we want to read. And there it is. We have another gzip tar file that actually has the policy, and then we have an MD5 checksum of that file. Perhaps you have a security gateway module that is having a problem with properly getting the policy for whatever reason. In expert mode, there is a useful command. This command has many options. One option, for instance, allows you to reset SIC globally, which is very handy. If you need to reset SIC on X number of security gateway modules, uh, that can be a bit of a process. You can use the ASG_blade_config command to pull config and specify the type of config from another security gateway module. So once you do that, you could run cp stop cp start, and if necessary, run cluster xl_admin up to get the clustering back out of a problem state if it is. Another command line command that is useful is the gupdate conf file command. So this command, it wants a config file to edit or to add an entry into, and you also have to provide a variable or key equals value pair. So I don't want to risk accidentally messing up a critical config file, so I'll just use a non-critical config file. And there's another top secret password for you. It always displays as asterisks for me. Anyway, the gupdate config file command will propagate this out. There's that test.conf file. I assure you it did not exist before. Let me prove it. It was created by this this utility. And there's the config file entry that was added. So you should have a very good reason to be editing config files. You're probably following an SK article or something like that. But this provides a convenient way to make the same change to that config file on all of the security gateway modules in the security group. Going back to CLI shell, global CLI shell. So this set SMO image command allows you to enable auto clone mode. Actually, before I set it, I want to show it. So auto clone currently is turned off. What auto clone does is it will clone the image of the single management object host onto another security gateway module in the security group if needed. So the module, or so the security gateway module will determine if it needs to be cloned through MD5 checksums. So the single management object host will generate an MD5 checksum of its configuration and propagate that out to all of the other security gateway modules. And if they have a different MD5 checksum, then they can pull config over. And this again can be very handy. For instance, if you have an appliance that fails and you get an RMA replacement, the new appliance is going to start off without the configuration. So image cloning can be one way to get it up to speed. Or if you add a new security gateway module to your security group, this can provide a way to get that to the same configuration as everyone else. Now, it should happen automatically. In some cases, it doesn't. And so image cloning can be useful. And image cloning can also copy over hotfixes and jumbo hotfixes, which can be very convenient. Next, I would like to go over this graphic that I'd already shown in an earlier module, but I just wanted to cover it a little bit more. Downlink interfaces between the orchestrator and the security gateway module use several different VLANs to separate different types of traffic. For instance, if we have, say, two uplink interfaces that have been assigned to this security group, traffic to and from each uplink interface will be sent from the orchestrator to the security gateway module through the downlink connection, and it will be tagged with a VLAN number of 1023 plus the port number on the orchestrator that received the traffic. And so if you have a management interface and a couple of uplink interfaces, management interfaces are sort of like uplink interfaces, then traffic coming into the management interface, the ETH1 management 1 will be VLAN 1023 plus number of interface. That's one, so it'll be VLAN 1024. If you have an uplink port of ETH105, it'll be 1023 plus 5 or 1028. A VLAN 1029 would be ETH1-06. So the different VLANs are used to separate the uplink traffic to and from. And then I already sort of discussed the other VLANs. There's a VLAN that handles correction layer traffic, and the correction layer again is there to make sure that NATed packets are always processed by the right security gateway module. So when a new connection arrives on the orchestrator, it'll use its distribution mode algorithm to determine which security gateway module in that security group should handle this connection, the traffic for this connection. And the distribution algorithm works in both directions. So outgoing traffic from this source to that destination, and then the return traffic from that destination to this source will always be sent to the same security gateway module. And again, technically, it's being sent to a particular downlink port on the orchestrator. You only have one security gateway module plugged into that downlink port, so implicitly that selects the security gateway module. So once we have determined the downlink port and the security gateway module attached to that should be handling the traffic for this connection in both directions, that security gateway module will be active for that connection, and it will then determine another security gateway module in the security group that should be backup, and it will start synchronizing the state of the connection to the backup. However, if NAT policy is in use, then perhaps the source IP address and or the destination IP address and even perhaps layer 4 ports may be changed as part of the NAT policy. So we have packets going out with a different source or destination IP address, or perhaps a different source port than the original packets that came in. And so when the return traffic, the return NATed traffic arrives on the orchestrator, the distribution algorithm will likely determine that a different security gateway module should be handling this traffic because it keys off of, depending on the distribution mode, source IP or destination IP or both or something else. And by default, it also looks at the layer 4 source port or destination port or both. So the correction layer exists to allow the security gateway module, which is handling the NATed traffic, to forward that traffic through this correction layer VLAN to the security gateway module that is handling the original traffic, because it has the state table entries. So we have the same security gateway module handling both the original and the NATed traffic. So it can, for instance, reverse the NAT for return traffic. And then the synchronization VLAN, that is useful for synchronizing configuration changes. Then there's the chassis internal network, which carries information between the orchestrator and the security gateway modules attached to it. So I hope this review of the command line commands that might be useful and of the downlink VLANs has been useful. Thank you very much for attending.